Hello everyone, welcome back to Fine Techverse. So in previous session we have discussed about APIs, SDK, and we also created a few projects like a chatbot, our own AI assistant which uses Gemini, and document analyzer. And now we are going to discuss about RAG, which is a very important topic in generative AI, and it is also known as heart of generative AI. First of all, we'll start with the problem. Suppose here I'll keep this funny.jpg as a file which we have kept in before session. So here in the contents, it will pass the uploaded file or particular prompt and history, right? So here every time we give a prompt, the file again and again goes to Gemini instead of storing there. Suppose like, so here we can see that a diagram that we send a file to Gemini through the client and it gives the response to our code, right? I mean to our terminal, right? So now see file, comma prompt. As we see in our code, in the contents page, the uploaded file and the prompt goes to Gemini, right? Let's leave the history for some time. So we are running this inside a loop, right? So the every time this block runs, the prompt gets appended to the here we can the prompt gets appended to the history, and history will be sent to Gemini at every iteration, right? Suppose if we give prompt here, it appends to the history list, right? And also it goes to that particular model like this. Okay, so the response also goes to that particular model. Okay, that's completely fine. But wait, but how many times it will go? Listen, the every time this particular loop runs, suppose let me run this program. So here it's asking to prompt us. So I'll give about this image that what's the color of shirt? Just normally. I mean this everything, the prompt which is appended by history, the contents, I mean the uploaded that particular uploaded file, everything goes to that Gemini, right? Now, and it gives response according to it. Okay. Now let's ask again. So let's ask that what's the file format? Okay, what's the image format? Okay, that I gave. See, the loop is again running from starting, right? Okay, it's JPG format. Okay, no problem. It's JPG format only. So here again from starting, it takes the prompt, appends it to the history, and the particular photo is uploaded again. That prompt is uploaded again, right? But how many times this will happen? How many times? I mean, the every time we give message to this particular AI model, the requests are sent to Gemini again and again, which leads to higher usage. So let's take a real world example. We have ChatGPT. It offers the free trial up to the mark like 3 images per day, like that. So what if we upload more than that? The usage will exceed and it will not let us to use again, right? So the same happens here. The every time we send this particular prompt, the file is sent to Gemini again and again. So if I give prompt 10 times, I mean, if I normally tell hi and it gives response, hello and it gives response, like that, if I continue this process up to 10 times, 10 times this file is sent to Gemini, isn't it? So, which leads to higher usage. So, this is the main limitation of it. This is the main limitation of this method. So, to overcome this, we'll use a concept called RAG, Retrieval-Augmented Generation, RAG. Sending this photo many times may be fine, but what if I sent a PPT with almost 500 pages? It is 100% not efficient. So let's learn about the methodology of RAG. I mean, how it works. First of all, here when a particular user asks a question, it collects the information from that particular database. I mean, from that particular image or PDF. Find only the relevant information. Suppose a PDF consists of 10 pages and our information is present only at one page. It only takes the information from that one page instead of searching everything and gives to Gemini that particular page. I mean, the text in that, I mean, the text or content in that particular page and our prompt goes to Gemini and it gives the answer. So look at the efficiency of this. Looks efficient, right? This is how RAG works. So this is the workflow of RAG. So if we give a particular PDF, it converts that PDF into chunks. Chunks means dividing the context into pieces. I mean, uh, suppose a PDF consists of 500 characters. Okay, 500 characters. So it is chunked into 100, 100, 100, 100, 100. Chunk 1, chunk 2, chunk 3, chunk 4, chunk 5. It is divided into chunks, right? So for that chunks, the embeddings will be created. Embeddings is nothing but, okay, let's explain this later. So let's concentrate on chunking first of all, right? So as we all know that chunking means dividing a large document into meaningful smaller pieces. So first of all, why do we need chunking? Imagine we have a PDF with 5 pages. One is about basics of artificial intelligence. Two is about machine learning. Three about deep learning. Four about generative AI. Five about AI agents. So we want the information about deep learning. So which page we should go? I mean, which page we should refer? Obviously, we will refer third page, which is about deep learning, right? That's what the chunking does here, right? It chunks that particular topic into pieces and searches the data through that chunks. Sounds efficient, right? That's what the process will happen here. Let's take an example. Here we have 5 lines of content about Python, right? So here the chunk one is first 2 lines. and chunk 2 is other two lines. Chunk 3 is remaining one line. Suppose if I ask what are the applications of Python, then it immediately searches for chunk 2. It is widely used in AI. See, look at the efficiency of this. Here now AI can search only for relevant chunk. Okay, it's clear. Now let's talk about chunk size. So we all know what is chunking. It's dividing the content, right? Making a particular document into pieces, anything, right? So how does this chunking happens? Because of chunking size. So let's talk with an example. Suppose we have chunk size of 500. Then what happens? Suppose our content, not this one, but a content like this. I mean a para. This consists of size 1,000 characters. I mean if that para contains of 1,000 characters, then if we give 500 as chunk size, then each chunk can contain up to 500 characters. That's what. Suppose its size is 1,000 and chunk size is 500. Then how many chunks will be created? Two chunks, right? Chunk 1, 500 characters. Chunk 2, another 500 characters. Totally 1,000, right? Suppose if I give chunk size 200, then chunks will increase. 200 characters, chunk 1, 200 characters, chunk 2, 200 characters, chunk 3. So here we can see the total sum is 1,000, right? So if I give chunk size as 200, then almost 5 chunks will be created. So here we can see that as the chunk size will decrease, the number of chunks will increase, right? Suppose if I increase chunk size, then chunks will decrease. So our next topic is chunk overlap. So okay, let's discuss about this briefly. Okay, let's start. Suppose if we have a sentence like this, sorry, Python is a programming language used in, oh sorry, AI, right? So suppose if we chunk it, chunk 1 equals to mm, Python is programming. Suppose if we give chunk size is 2, chunk 2 equals to language used in AI. So to that particular AI model, if these both chunks will go, sorry, not these both, if the relevant chunk will go, so there is a relationship between programming and language, which is broken because of chunking, right? Because the sentence was split in middle. So for solving this kind of problem, we'll use chunk overlap. So I'll write chunk overlap equals to 10, suppose. Then our chunk becomes, our chunks become chunk 1 equals to Python is a programming language used in AI. So here what happened? The programming language appeared twice, right? And now what's this chunk overlap? Why this chunk overlap equals to 10? Because the last 10 characters of previous chunk should include in starting of next chunk. That means, right? Suppose if I give some 20, the last 20 characters of this chunk will appear at beginning of chunk 2. So we'll use this for correct formation of sentence, right? So our next main question is how to use chunk overlap. So 0, so that anything will be not repeated. It's fast, but context may be lost, right? And now 10 to 20, it's a small overlap and good for short text, right? And 50 to 100, common for documents with long sentences or paragraphs. This is mostly used in big companies. In big companies, if they use this concept, almost the chunk overlap between 50 and 100, right? Which is very common for accurate results. So theoretically, it's fine. But while coding, how can we chunk that particular document? So let's understand it now. So let's create a file called chunking.py. So for chunking, we'll use a Python library called LangChain. We need to install our LangChain library, right? So pip space install space LangChain Google Gen AI, because we'll be using Google, right? Google Gemini, right? So I got a spelling mistake, sorry. Yeah, I think it's perfect. Yeah, it's working fine. So it's done, guys. Now let's import it from LangChain dot text splitter. From that, import recursive character text splitter. So here every starting word is capital, right? For character, for recursive, for text, for splitter. Starting word is capital, right? So this is a LangChain utility which which splits the large document into smaller pieces. So for chunking, this will be useful for us. So here we need to create a variable that splitter equals to our recursive character text splitter. Inside that, we need to write our chunk size and our chunk overlap. So our chunk size, sorry, so our chunk size equals to, oh sorry, 500, and our chunk overlap equals to 100, which is ideal one. I have told this before, right? Also, our chunk size will be 500. So we have prepared everything for splitting, right? Now we need a particular document and we need to load the document here. So for that, we'll use another LangChain utility from LangChain community import. Okay, LangChain community dot document loaders. So kindly observe the underscores, guys. So from this, we need to import py PDF loader, right? So kindly remember this, guys. Is a very important. So this reads the PDF, right? So now we need to get the PDF. So let's give this right. So this is a PDF, guys. So now we need to create a variable called loader, which is equals to our py PDF loader inside the parentheses by keeping these double quotes. We need to write that particular file name. So dot PDF, right? So now we need a variable called documents equals to anything, not only documents or not only loader, or variable loader dot load. Okay, now we have loaded the document too. Now what should we do? We should chunk equals to, sorry, splitter dot. Remember, guys, this is the method split documents from our variable documents from which we loaded our document. right? So let's see the total number of chunks. So for this, I'll use len method. Fine. Yeah, 27 chunks. So now let's print the chunks. For let's loop comma chunk. Let's create a variable called chunk and I in enumerate chunks. Okay, I don't want to confuse you guys, so I'll make it simpler for you. So I'll take a variable called count, which is equals to 1. So here chunk for chunk in our variable chunks, do this. So it should print the count like first chunk, second chunk, like that. Count. So next print our chunk dot page content. So this page content method prints the each chunk at particular index. So we'll increment our count plus equals to 1, right? So let's run this. I'll remove this. Okay, let's continue. Okay, I think it's not good. Okay, let's clear the terminal too. So, okay, these are the chunks. So count 1. So this is one chunk. Up to here, this is one chunk. So, okay, instead of count, I'll keep something like chunk, which would look simpler, right? Okay, now let's clear the terminal. So let's run it. Yeah, fine. So chunk 1. So it's chunk 2. It's chunk 3. So chunk 4, chunk 5, chunk 6. Okay, yeah, anything it might be. Okay, it's divided into chunks, 27 chunks, right? So our next topic is embedding. And embedding is nothing but a meaningful representation of text. Like a particular text is represented as numbers in decimal form. So here in this diagram, we can see that the text which is entered by us goes to the embedding model. Embedding model is nothing but it creates embeddings for that particular text. And the embedding model converts that particular text into numbers. So here, as we can see that here is a text called Python is a programming language. Using that embedding model, it has created that text into numbers, a list of numbers like this, which are represented in decimals. So don't feel tensed about these numbers. Don't care them. A model handles these all, right? These embedding vectors can, I mean, not vectors. Okay, let's talk beginner friendly. This number can produce us the similar meaning to that particular text, right? So here, Python is a programming language. So let's take another text like representing the Python. The best example of programming language is Python. They both are quite similar. So these particular numbers will also be similar. So this is the use of these numbers, right? Okay. Don't stress about them. So let's take another example. Here we have artificial intelligence and we have AI. So both are same. Only this is the long form, this is the short form. That's it, right? So these embedding numbers will be similar. Okay, that's it. So let's code it. Let's create another file called so we need to install a library for it. Pip space install space LangChain dash Google dash Gen AI. So let's continue. Okay, okay. It's already installed. It seems fine. So let's import it from LangChain. Oh, sorry. Google dash. Okay, it's underscore man. Sorry, sorry guys. Okay. Oh, Gen AI. From that, import. Now we need to import Google Generative AI Embeddings. Right? Remember this, guys. This will be useful for creating embeddings. So here, let's create a variable called embeddings equals to, oh sorry, equals to. So here, let's select our model. Okay, sorry, Google Generative AI Embeddings. Same as here. So here we need to select the model. Model equals to, for creating embeddings, there is a Google model, but not like Google, sorry, Gemini 2.5 Flash, not like that. It has a separate model. So we'll write it as models dash text, oh sorry, text dash embedding dash 004. So this is the model for creating embeddings. Okay. So here we need to insert our API key. So for that we need to write a variable like Google sorry, Gemini API key. It's fine. So here we need to insert our API key. So I'll insert this one, but don't expose your API key. I'll delete this as soon as our session completes. Okay, don't forget it, guys. Yeah, it's done. So we need to insert comma here. Yeah, now it's complete. So okay, let's test it. So we'll create a variable called vector, which is equals to okay. First of all, what is vector? So as we saw that the random numbers, a list of random numbers which are in decimal form, right? So this list is known as vector. Okay, remember it, guys. Vector equals to embeddings dot embed query Python is a programming language. Similar example, right? So this is the method which is used for creating embeddings. Remember it? So now let's print our vector. Right, completely fine. Okay, I think our API key is incorrect. Let me check, guys. Yeah, here we need to write Google, Google API key. Remember it, guys. But insert the normal Gemini API key. That's not a problem. So let's print vector. Let's try again. Seriously? Oh yeah, Google has changed the model name. It seems. Do this. Yeah, sorry, Gemini. So we have got the error. The error is with this. Previously it used to be 004, right? So it's 001. Okay. So let's run it. So here we can see that it gives a big vector. See, starting from here itself and ends at here. And the length of vector is 3072 characters. Here, each chunk becomes an embedding. So as we see here, here it is chunk 1 and embedding 1 for that particular chunk. Chunk 2, embedding 2. Chunk 3, embedding 3. For each chunk, each embedding will be generated. So we have created embeddings for each chunk. Where do we store them? Here comes the topic called vector database. So here there are 200 chunks with 200 embeddings, right? So where do we store them? In a normal Python list, embeddings equals to our list It's okay for 200. I mean, it's okay for 200 embeddings. It's quite good. But what if we have 10 million embeddings? Then will the Python list searches quickly? Obviously, no. So, what do a vector database do? A vector database stores the embeddings and helps to quickly find the most similar embeddings to get accurate results. Got it? So, have a look here. The chunks which are converted into embeddings, and embeddings are stored in vector database. And in the vector database, there is a similarity search of that particular embeddings, right? The most near embeddings means the similar meaning. Let's show an example. So here if I enter instead of Python, I'll enter something like artificial intelligence. Artificial intelligence. This is one, right? Oh, sorry. This is vector one. And here we have vector two with only AI. Okay. So let's print vector one. I'll clear the terminal. So for this vector, the starting is like minus 0.0007, something like this. Just remember this. I mean, just remember the starting sum of them. So again, let's print vector 2, right? Yeah, right. Okay, okay, right. So here, look, both of the vectors are slightly similar, right? Similar means they have same meaning. That's it. So this is the concept of embeddings. So we may also get a doubt that why not SQL for storing these? Why only vector database? So let's clarify it. So SQL is ideal for data like, I mean, it should be structured like or details, something like that. It's not ideal for storing these vectors, right? Isn't it? Does it store efficiently? Obviously, no. So we'll use vector databases. So now let's discuss about FAISS, Facebook AI Similarity Search. It's a vector database. Use it to find similar vectors very easily and efficiently. So let's install this particular FAISS package. So for that, pip space install space FAISS dash CPU. Okay. Okay, sorry, guys, I wrote the spelling wrong. So let's correct it. FAISS dash CPU, right? It's installing. By the way, this FAISS is developed by Meta. So our installation is completed. Let's import this particular package. Okay, so let's go to our chunking file and let's import it from LangChain community dot vector stores. Import FAISS. Okay, okay, the name is correct. Remember this, guys. No way. We need to remember this. Kindly note these following commands and remember these carefully. Now we need to create the database. So for that, DB, which means database. Okay, DB, which is equals to from our library FAISS. Mm, okay, dot from underscore documents. Here we need to give the documents to store that in the database, in that particular vector database, right? So now we need to give the content, our chunks, our chunks and our embeddings too. So let's do one thing. Let's also import the embeddings here, right? Now we need to create that particular embedding model. Okay, it's good. Yeah, that's it. Okay, let's avoid the confusion. Let's create a separate file for it. So let's code from scratch itself, right? So let me explain you guys about the FAISS somewhat deeply, right? So let's understand. So as we all know that when we upload a particular PDF, it divides that into chunks, right? Which means pieces, and converts that into embeddings, and that particular embeddings goes to FAISS database, which is known as vector database, right? So when we ask a question, when we ask a query about that, it converts that question into embedding and sends that to FAISS database, right? So our question should match the chunks embeddings, right? So let's take an example. Hmm, yeah, okay. I think this is good. So okay, we have a para here and it is divided into chunks, right? So what if I ask a question that what is difficulty of Python? So we all know that this question also will be converted into embedding and gets stored in vector database. And also each chunk is converted into embedding, right? It's perfect. Then our embedding vector should match that particular chunk. I mean, that particular chunk. So, if both of the embeddings matches, then that particular chunk is the answer. That's it. Okay. So, this is converted into embedding. Suppose example some 0.25 comma some 0.3 sorry 387 like that. Anything it might be. Some okay. Dot dot dot. Something it might be okay. So imagine this is an embedding for it. So for this chunk 3, imagine it is an open source. So we have asked what is the difficulty of Python. This is not the answer, right? So these both embedding vectors will not match. So this embedding vector will be some 1.258 comma 3.987. Okay, 988. Anything it might be because these both doesn't match. And coming to chunk 2, it supports object-oriented programming. It is widely used in AI. Is this an answer for this question? Obviously no. So, oh yeah, right. The embedding vectors will be different, comma 6 point something, anything it might be. We don't want to bother about these embeddings, right? Just a particular model of Google creates that embeddings. Just leave it. Okay. So now, what is the difficulty of Python? It is our question. So these both of the chunks doesn't match that particular answer, right? So their embedding vectors are different. I mean, they are not matching. At least they are not similar, right? So coming to chunk 1, Python is a programming language. It is easy to learn. So this matches to that particular question, right? So the embedding vector will be similar to this. It is 0.25. So 0.23, something like that. I mean, it should not be exact. It may be, but it should be similar. Some 0.380 like that. Okay. So this embedding vector matches this, right? Then you'll get a response that for this question, answer is this. So don't think about how the embedding vector is created for this and how it is created for this. How does it know that this embedding vector will be similar to this? I mean, how? Don't think about them. Guys, got it? That's almost no longer useful to us, right? So we must know that for answers to that particular query, the embedding vectors must match. That's it. I mean, not completely, but similar, right? That's it. Don't remember anything, right? So now let's code it from scratch. So first of all, we need to load a particular PDF. So for that, from LangChain community dot document loaders. Sorry, import PDF, sorry, mm, py PDF loader. That's it. Mm, yeah. Oh, now it's fine. So now, after importing, what should we do? We should chunk that particular document, right? So for that, from LangChain dot text splitter import recursive character text splitter. So we need to import that, right? Yeah. So let's normally run it. Nothing happens, just normally. Yeah, I think we got an error. Yeah. Okay. Now let's resolve this. Small errors leads to big mistakes, right? So we have imported our PDF loader, which loads PDF, our text splitter. I mean, which makes chunks from our document, right? So what's next? For that chunks, what should we do? We should create embeddings for them. So for that, from LangChain underscore Google underscore Gen AI. I know it's hard to remember them, but we don't have an option, right? So from this, we should import Google Generative AI embeddings, right? Sorry. So we have imported. So we have created embeddings. So next, what should we do? We should store it in vectors, right? In which vector database? FAISS vector database. So we should import FAISS. So from LangChain community dot mm, yeah vector stores import our model FAISS. So we have imported all of them, right? We know what the each library can do. So now let's start. So at first we need to load the PDF. So for that, okay, sorry, loader equals to py PDF loader. We need to give our particular PDF name. So let's give something resume dot PDF, right? Now we have imported that document. So we need to load it. For that, documents equals to loader dot load, right? So we have loaded the document. Now, next, what should we do? Okay, I'll give some space for it. Now, next, what should we do? We need to chunk, right? So, splitter equals to our recursive character text splitter, our library. So inside that we we have to give our chunk size and chunk overlap. Chunk size equals to 500, and now chunk overlap equals to 100. It's fine. Now we need to split. Sorry, okay. Chunk it. Chunks equals to splitter dot split. Okay. Split documents method. Inside that we need to keep our document. Yeah, it's fine. And by the way, LangChain underscore text underscore splitters. Remember it. So now coming back to our topic. So we have created our chunks, right? So chunking is completed. So next, what should we do? We need to create embeddings. So our embeddings, which is equals to Google Generative AI embeddings. So inside that, we need to keep model equals to models dash Gemini embedding dash 001. So this is our model. Okay, remember it. And next, we have given the model. Next, what should we do? Obviously, we need to give our API key, right? Hmm, yeah, Google API key equals to our API key. So let's take it from here. Make ensure that you don't expose it. I'll delete this API key as soon as my session completes, right? So make ensure, guys. Okay. Yeah. So we have given our API key. So now we need to create our vector database. So variable DB, which is equals to our library FAISS. mm, from yeah, from documents, from documents. So we need to give our chunks and our embeddings model. So why do we need to give this both? Because it takes our chunks and makes it into embeddings and stores in that particular vector database, right? Got it. So kindly remember it. So now everything is over. We have created a database, vector database. We have made embeddings, we have created sons, we have loaded the document, everything's done. Now what's left? We need to save the results. No, sorry, we need to ask the query first. Query equals to, I'll give something like, what's this file about? Okay, so now this is a query, right? So now our results equals to our database db dot similarity search of our query, uh, of our query, comma, k equals to 3. So what is this k equals to 3? Let's discuss it, no problem. So guys, everything is done. Now we need to just print. I mean, we need to just generate the output. That's it. Okay. So let's continue. So for that, we need to use for loop for doc in results. So we need to traverse all over the results, right? And we need to print. I mean, we need to traverse over each of the part and save it in doc. And our doc dot mm, page content. Oh, sorry, page content. Yeah. So let's give it a try. Okay. Oh, okay. We need to rename it, right? So I have kept this particular library name as my file name, which is completely wrong, right? So FAISS demo. It's fine. Okay. So let's run it. Yeah, finally we got it. So here we got an information about this file. So we have asked what this file about in basic English. Okay. So it has given response like Institute of Aeronautical Engineering about this. Okay, right? So it gave the response from our file. So it's good. So let's do one thing. I'll give this query as input. Enter your query. Right. Yeah. Okay. So let's run it again. So compared to our previous one, which I have showed in part one, this it is very efficient. It is very, very efficient. Okay, guys. So this is known as RAG. So let's enter our query. What's the okay, institution name? Right, Institute of Aeronautical Engineering. Yeah. So here we can see that it's only giving the reply from that particular PDF itself. Like it's giving the content from that PDF, which is useful. I mean, whatever we ask, it's giving that directly instead of any explanation, right? So this is known as retrieval. I mean, it's retrieving the information and giving the response. Okay, it's good, but this is only somewhat, right? We have still many of things to learn. So let's continue. So what's happening here? So our query is sent to this particular vector database, right? Sorry. Also the chunks are sent and embeddings are sent. So why are chunks are sent? We all know that chunks goes to that particular vector database and converts into embeddings. So okay, we all know that. So again, our query goes to that particular database and that particular query also convert to embeddings. So the embeddings of query, if matches with any chunk, that is the answer. That is the only answer. I mean, it gives only that particular answer instead of any matter, right? This content is just available in PDF, right? So now let's discuss about this K. So what is this? Usually our AI models like ChatGPT, Gemini, Claude uses this plays a major role because when a query matches with a particular embedding, I mean a query's embedding matches with a chunk's embedding, a particular one. So this chunk one, if we give 3, it also gives the preceding chunk and succeeding chunk to that particular vector database, and it also gives that as a response to generate more content, right? Usually if we ask a small question for ChatGPT or Gemini, it gives a large answer. Why? Because of this. Got it? So what if I give k equals to 1? Let's test. So let's check. So fine. Enter your query. So give the schema of this. Schema means the particular skeleton or structure of it. Right. So it has given a very small response. Okay. Right. The details or the percentage, anything it might be. Right. Got it. So this is how it works. Got it, guys? So this is K. Just remember it. So congratulations. We have built our first RAG application. But a big AI models like ChatGPT, Gemini uses the advanced RAG, right? More than this, something more than this. So let's learn about it. So yeah. So every time when I run this program, the PDF, loads and becomes into chunks, and embeddings will be created, and it creates the vector database. And the query also sent to vector database. It searches for the nearest embeddings and gives the response, right? So every time we run this, the same process happens because, I mean, why? Why every time? Because we have gave only this PDF, right? So the creation of embeddings takes time, right? So why don't we save those embeddings, right? It's one PDF. I mean, I have given only one PDF. It's completely fine, okay. But what if I give 20,000 PDFs? The each time I run this program, it always creates the embeddings again and again. Is it good? Obviously not, because it's inefficient, right? So let's save those embeddings into our local database. Okay. So we'll follow the principle like create once, reuse forever. Sounds crazy, right? Now for that, we need to do db dot save underscore local. Inside that, we need to write a file name where we can store all the embeddings like embeddings underscore FAISS, something like this. Yeah. At last, we want a print statement like save locally, something like this, right? Yeah. Let's run it. Mm, okay. Okay. So let's start. Yeah. Saved locally. Okay. So here we got a file called index.fias. So this is something like this, and this is, yeah. So these are our chunks, right? So here is our chunks, and this is our embeddings. Looks something like this, which we cannot understand. Let's leave it. So the the data which is present in that particular vector database should be saved locally with this file name. We are giving this command, right? Now, this is reusable, right? So, now the question is, how can we load it? Not only in this file, I mean, not only in this particular code, we can load it from anything we want because we have saved this in this folder. So, it's reusable. So, mm, so I'll give name something like this. So, don't mind. So, let's import from LangChain underscore Google underscore Gen AI import. Oh, sorry. Google Generative AI embeddings, right? So, for embedding purpose, I mean, for we'll use this for mm, give these embeddings to the Google, right? We have to send these embeddings to Google. I mean, Google Gemini AI. Okay. So next we need to import LangChain underscore community dot mm, vector stores. From that import mm, we need to import FAISS, right? So importing is completed. So mm, we need to create embeddings file. Embeddings, which is equals to Google Generative AI embeddings of our model equals to models dash text dash embedding dash 001. So this is our model. We all know it. Okay. So okay, sorry guys. So we need to give our API key now. Now Google API key equals to our API key. So okay, I'll give this API key. Right. So now we have created embedding model, right? So now what should we do? We should load this particular file. So for that, our variable db equals to mm, mm, yeah, our files dot load local. I mean, we need to load it. Load our file name, which is embeddings underscore files, right? Comma. We need to load that folder and our and we need to give our embeddings, and also we need to give a boolean variable called allow dangerous deserialization is equals to, we need to give it as true. So what is this? So we are telling something like this: embeddings underscore files is completely safe. We are telling something like to this. Okay. So we need to give it. You must give it. Okay. And now we have loaded it. So after this, our file will be loaded. Then we can print a statement like yeah, loaded successfully. So after this, what should we do? We should ask query. Query equals to our input. So let's give an input. So after that, we all know what to do. So our result, which is equals to db dot similarity search of our query, comma, or k should be 3. K equals to 3 is ideal. Okay, guys. So now we know how to print these for doc in our variable called result. So print doc dot mm, page content, right? So let's do one thing. Let's print 50 small dashes, something like this, for clear output. Okay, so let's see the output. Yeah, it's loaded successfully, and it should ask input. Yeah, it's asking input. So let's ask about the schema of the PDF, right? Okay. Oh, okay. I think. Okay, okay. Oh, sorry, guys. The model name is models dash Gemini dash embedding dash 001. Sorry, guys, for inconvenience. Okay. Yeah, it's loaded successfully. It's asking for input. Describe the content. Okay. We'll ask one question. Hmm, what we'll ask? Okay. Let's have a look at our PDF. Hmm, so let's normally ask about academic year, right? Okay. Yeah. Okay. It's fine. So it's giving direct response instead of giving random responses like normally a chat GPT gives, right? Yeah, I got your response. Something like that. It's giving direct answer. So next, we are going to discuss about multi-rack PDF. Our rack pipeline can only, it can only take the information from only one PDF. But in real world, the systems can take data from multiple files and they can give response according to it. So let's build a multi-rack system. So here let's create a file named documents. So in this file, there should be multiple PDFs. So let's keep some random PDFs. Yeah, yeah, okay, 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 it's fine. We'll give three PDFs. That's enough. And now, yeah. So now, for reading PDFs, what which which library we have used? PDF loader, right? From this same package, we need to import another library with this, which is called directory loader. Fine. The reason why I have imported it, the PDF loader can read only one PDF, but whereas directory loader can read multiple PDFs. Okay, now we should change our loader to directory loader, and here we need to give a particular folder name, which is documents. And now we need to create a variable called globe, which is equals to star dot pdf. I think somebody of you guys understood what is this. So loader underscore cls equals to py pdf loader. So let me explain this. Here this directory loader takes the files from documents folder and takes that PDF, that file name. Suppose this file name is final one, right? So this load variable is okay. It's globe. Okay, the globe variable is star dot PDF means for every file in this PDF, at last we must attach dot PDF. We are saying to Python, right? So loader underscore cls equals to py PDF loader. So this means we take a particular one file from documents. We take this file and attach it at last dot PDF, and we give it to py PDF loader to read, right? To read and to load it. And once again, it takes another file attach dot PDF and loads it. That's it. It repeats, right? So let's print our length of this documents variable. Okay, documents. Yeah, 33. Okay, 33 means don't think that these are this represents how many files are there. This represents the total number of pages in all three documents. Okay, got it. So there are 33 total documents here. Okay, and here everything is same. No need to change anything. Okay, so now let's run it. Yeah, okay, right. Okay, Okay, it's asking for query. What is this row? Something like this. Yeah. So okay, it's giving the detail about that particular report and also the team members. Fine. Okay. I mean, which means it's going to that particular embedding and giving response properly. That's okay, good. Okay. As my PDF is not proper because my PDF is not properly organized. So it may behave like this, but no problem. It's working good. Okay. It's working good. So these are the team members of this particular project, right? So let's discuss about metadata. Suppose if we ask a question to this chatbot, it gives a response. Okay, that's completely fine. But we don't know that from which PDF or which page the answer will come. For that cases, we'll use metadata. So the best example of metadata is your photographs. I mean, if you take a particular photo from your mobile, then you can see a watermark showing your time and date. So that is known as metadata. Okay, fine. Yeah, here. Now let's print our normal documents. Suppose if I print documents at index of 0. Kindly have a look. So here we can see that producer, creator, okay, date and time, source, documents, final one dot PDF, total number of pages, and page is 0, page label. Okay, it's fine. I mean, total pages are 23. Okay, good. So, yes, see, page 0, index of 0. Okay, suppose if I give index 1, suppose. So, kindly have a look. Page 1, page 1, right? So, kindly have a look. I mean, this document variable stores the both content and the metadata, right? About where the data is stored, how many pages it consists of, and the particular page or information or identity about it, anything it might be. This documents variable stores both of them, the data which we give from PDFs and the metadata, which represents the characteristics of that particular document, right? So let's try printing only the metadata dot metadata. Fine, fine. Let's run it. So here we can see only the metadata, right? Total number of pages, page number, anything it might be. So this is metadata, which represents the characteristics of that particular document. Usually in Python, page counting starts from 0, unlike our human we start from one, right? But in programming languages, counting starts from zero. So here, let's go to this. And in our loop, it should print page content or page number and the particular heading or anything mm, like a source. Okay, so let's print. So we should give like this. This represents the source of that particular document. I mean, it came from which document. It gives the document name and it gives the page number. Okay, so as we all know that it gives the content of it, right? Okay, so let's run it again. So it's asking for query. So I'll give what is row, something like this. Okay, good. It gave the information about our field project. It's good. Okay, so documents is row one.pdf. Okay, I mean it's good. It's really good, right? So it's good. I mean it's giving responses properly according to our data. It's good, but is it complete? Mostly no, because it's giving only the data. It's not giving the answer for that for our particular question, right? So this is the last part where we make a complete RAG application. So let's create a variable here called something like chat history. Fine. It is a list data structure, right? So here, so also let's create a variable called context, which is equals to mm, which joins our sorry, only join our result, our result dot page content, the content, right? Okay, stores this. It need to store all the content, right? So we need to loop all over the document. So for that, for doc in result, it should traverse all over the result, right? So for that, so our context will be like this. Context will be like this. So let's give a prompt to AI that should give this context, our query, and mm, previous chat. Those three should go to AI and it analyzes them and gives the response. Fine. So now our variable prompt, which is equals to, so inside this, we need to write a prompt to AI. You are a powerful AI assistant. You are a powerful AI assistant. Firstly, give your previous chat. Previous chat. equals to, sorry, previous chat or chat history variable, right? And our context. We need to give our context, which is our variable context, and we need to give our query. So, question, okay, which is query. So, mm, only give information regarding to this only. Okay, now let's import Gemini. Okay, sorry, from Google, import Gen AI. Okay, so now I have given the prompt. So we need to do our response, which is equals to, mm, oh, first of all, we need to create our client, right? So our client equals to Gen AI dot, mm, okay, client, mm, okay, our API key, right? Our API key equals to. So here we need to give our API key. So fine. So now we need to generate our response. Response equals to client dot, client dot models dot generate content. So in this, we need to give our model. I mean, what is the Gemini? What is the Gemini model we want to use? Which one? Gemini 2.5 Flash, which is the efficient model, which gives the best responses within low tokens. I mean, low credits, right? So our prompt equals to, sorry. Our context equals to prompt, and that's it. Mm, contents. I'm so sorry, guys. Okay, contents equals to prompt, right? So we have given our prompt, and we also given our model. Okay. So now, so as we all know, our answer is equals to response dot text, right? So we'll print our answer. Got it? So now, after printing the answer, okay, let's remove this. After printing the answer, we need to append that answer and our question to chat history, right? Now, chat history dot append. Mm, F user, and we need to give our query. Yeah, exactly. It's query. It's fine. Okay. Now, mm, answer. This can help AI to store, I mean, to locate what the user queried and what the AI answered so that it can understand better and give responses more accurately. Got it? So, we have did everything almost. But after asking of one question, I mean, if we ask one question, it gives answer perfectly and exits from terminal. So, as we did before, we need to insert a loop input. Uh, I'll give something like u. Fine. Now let's give a loop. Oh, okay, sorry. While true, which means the loops run. I mean, this loop run each and every time. It's perfectly fine. Also, if we type exit, if query equals to exit, so then break out of the loop. Fine. Something like by message. Oh, okay. Bye bye. Mm, okay. Bye bye is enough. Okay, right. So let's run this. Okay. Okay. Oh man. So I have changed my API key. So let's try again. Okay, good. So it's asking for a prompt. So let's give what's the following files about. So guys, our code is 100% correct, but my quota has been exceeded, guys. So kindly don't mind. And but our code is 100% correct. Okay. So okay, okay. Let's give another try. So this is the last try, guys. Okay. So now, okay, cool. Okay, it's working. Okay, guys, I took from another Google account and kept a powerful model. So it's working properly. So, okay, guys, it's working finally. So that's it for today, guys. In today's session, we have discussed complete RAG, about complete RAG pipeline. In next session, we are going to discuss about fine tuning, which is the most important concept in generative AI. So stay tuned for more updates. Subscribe and like to this video. Also share it with your friends. Jai Hind. By the way, I'll upload this code in GitHub, guys, so you can kindly refer it. Okay. So again, Jai Hind.